Hi guys, here's the last page of Test 2B review. Number 12, can a polynomial cross a horizontal asymptote? You betcha, yes it can. Polynomials can cross horizontal and oblique asymptotes. Remember, both horizontal and oblique asymptotes really help you determine the end behavior of your graph, but in the middle it can cross them without a problem. However, graphs can't cross a vertical asymptote. Horizontal asymptotes, oblique asymptotes, you can cross those, but not a vertical asymptote. All right, for number 13, it says the graph of this function has a vertical asymptote at 4. Well, if it has a vertical asymptote at 4, I know x minus 4 has to be in the denominator. And so it looks like here I've got a difference of 2 squares. So if negative 4 is part of that, then this would have to be positive 4 over here. And then if I were to multiply these guys together, I'd get negative 4 times 4. So this would be x squared minus 4x plus 4x cancels out. Negative 4 times 4 would be minus 16, which means the c needs to be 16. Number 15, find the intercepts and asymptotes of this rational function. First thing I'm going to do is factor it out so I can see in its most simplest form to make sure I don't have any holes. But when I factor this one out, I see nothing cancels. So my vertical asymptote would be x equals 1. My horizontal asymptote, same degree on top and bottom, so it's leading coefficient divided by leading coefficient, so y equals negative 5/3. If I have a horizontal asymptote, I do not have an oblique asymptote. For my x-intercept, that's where my numerator is equal to 0, so it's going to be negative 5. And then for my y-intercept, that's where we plug in 0 for x. So this would go away, and I'm left with 25/3. And that's number 15. Number 16, we're solving polynomial inequality. So if I put these guys on a number line, I've got an x at negative 3, at 2, and at 10. This is a cubic function because I got 1, 2, 3 x's, so cubic. Positive leading coefficient, so it's going in this general direction. So I know my end behavior is negative down here, positive up here. And each of these guys has a multiplicity of 1, so I'm going to cross at each of my zeros. All right, and then it asks, when is it less than 0? So I'm less than 0 between negative infinity and negative 3, and between 2 and 10. All right, number 17, same thing, except for this time our multiplicities are quite higher. So here's my number line. My 3 zeros are negative 5, 1, and 2. The degree of this polynomial is 3 plus 2 is 5 plus 4 is 9. So again, it's going to be a cubic shape, which means my end behavior is negative down here, positive up here. But now we have to be careful with our factors. So at negative 5, I have degree 2, so it's going to bounce. It's going to come up to 0 and then bounce back down to negative. At 1, I've got an odd degree, so it's going to cross. And then at 2, it's even degree, so it's going to bounce back and stay up here at positive. Now here's where it gets even a little bit more trickier. I want to know when I'm less than 0, not less than or equal to 0, but less than 0. So I'm less than 0 between negative infinity and negative 5. And between negative 5 and 1. We have to be careful because what's happening at negative 5? Remember, this is an x-intercept, so at negative 5, my graph is equal to 0. It didn't ask me when am I less than or equal to 0, it said just less than 0. Had for some reason this said less than or equal to 0, that would have changed it to be negative infinity to 1, including 1, because 1 is a 0, negative 5 is a 0, and then we're negative in between there, so we could include that entire interval. So, there we go. And number 18, so this is one of our work questions. So we got 2 people working together, can do a job in 4 hours. How long will it take the slower person to do the same job if one of them is 2 times as fast as the other? So the way we set up these problems is always the same. So the amount of hours it takes them is usually what we call x, and a lot of times we're solving for that. And we say x, the number of hours it takes, divided by the rate at which the first guy works, plus the number of hours it takes, divided by the rate at which the second person works, is equal to one job. So if I take the number of hours we work, divided by the rates at which they work, it should equal to 1. So most of the times, like I said, we'll give you the rate of this guy, the rate of this guy, and then you're going to figure out how many hours it takes to do that job. But this time they don't give that. They give us the total number of hours. So instead of having x over a, I'm going to have 4 hours over a and 4 hours over b. And what I don't know is how fast these guys work. But I need to get rid of either A or B, and fortunately they give us another piece of information. They said one person works 2 times as fast as the other. So let's say A works twice as fast as B. Now I can use this, and this is really like a system of equations, where this is one equation and this is another equation, and I'm going to use 2B and substitute it in for A. So instead of writing A, I've got 2B. And now we are going to find a common denominator and add this so that we can solve it out. So what is my common denominator between 2b and b? That would be 2b. b can go into 2b, but 2b can't go into b. So 2b is the common denominator. I didn't change my denominators for the first fraction, so the first numerator stays the same. For the second fraction, I had to multiply b times 2 to get to the common denominator, so I'm going to multiply 4 times 2. To get to the numerator. And so then this would be 4 plus 8 is 12 divided by 2b is equal to 1. And so 12 is equal to 1 times 2b. Dividing by 2, b is equal to 6. So this is where you have to really think about it. Okay, 6 hours. Is that how fast the faster guy's going or the slower guy? Well, b is 6. If I plug that into a would be 2 times 6, which would be 12. So which of these guys is working slower? A. So my answer would be 12 hours. And that's it for your review for test 2B. Good luck studying tonight, guys. If you have questions, please feel free to email me. I look forward to grading some wonderful A's on your test tomorrow.